Today we are going to discuss about the pelton wheel, whereas pelton wheel or pelton turbine is the same thing, whereas pelton turbine is a tangential flow impulse turbine, whereas inlet has kinetic energy, outlet has kinetic energy. In case in the pelton wheel, the water strike the bucket along the tangent of the runner, whereas water strikes the tangent of the runner. The energy of the energy available at the inlet of the turbine is kinetic energy. The pressure at the inlet and outlet of the turbine is atmospheric pressure. The turbine is used for high heads and named after L.A. Pelton, an American engineer invented this pelton wheel. Whereas figure shows hydroelectric power plant which has turbine is power plant. Around that there is a fixing of vanes. The water from the reservoir flow through the penstocks. The water of the reservoir flows through the penstocks, and at outlet which a nozzle is fitted, the nozzle is increases the kinetic energy of the water, whereas nozzle is increases the kinetic energy of the water flowing through the penstock. At the out of the nozzle, the water comes out in the form of jet. Out in the form of jet which strike the buckets, nothing but vanes of the runner. So turbine starts rotating. In case of the main parts of the pelton wheel, first one nozzle and flow regular arrangement, casing, runner and buckets, braking jet. In case of nozzle and flow regulating arrangement, the amount of water striking the bucket of the runner is controlled by providing a sphere which is regulates the water flow in the nozzle. The sphere is conical needle which is operated by hand wheel or automatically in an axial direction depending upon the size of the unit. If you can handle with hand, we will operate with hand, or else we will fix a automatic mechanism. When the sphere is pushed forward, the water flow will be reduced. In case if we pull backwards, if we pull the sphere backwards, the water strike in the runner increases. Whereas second one, runner with buckets, you can see that the runner and the buckets, whereas figure shows the runner of the pelton wheel, it consists of a circular disc. On the periphery of the which number of buckets evenly spaced are fixed. But spherical buckets are evenly fixed around the periphery of the pelton wheel runner. The shape of the bucket is double hemispherical cup or bowl. Each bucket is into two symmetrical parts by dividing the wall, which is known as splitter. Which divides the wall is known as splitter. Runner with buckets, the water strikes on the splitter and splitter divides the jet into two equal parts, and the jet comes at the outer edge of the bucket. The buckets are shaped in a such a way that the jet gets deflect అవుతుంది after striking the water. Bucket పైన వాటర్ స్ట్రైక్ అయ్యాక డిఫ్లెక్ట్ అవుతుంది around 160 to 170 degrees. The buckets are made up of cast iron, cast steel, bronze or stainless steel depending upon the head at the inlet. Based on the head at the inlet, we choose that metal, cast iron, cast steel, bronze, stainless steel of the turbine. Whereas casing, the figure shows pelton turbine which casing, a function of casing is to prevent the splashing of water and discharge water to the tail race, and it acts as a safeguard against accidents. It's made of cast iron fabricated steel plates. The casing of the pelton wheel does not perform any hydraulic function. The casing is not involved in the process of turbine. Whereas braking jet, nozzle is completely closed by the moving the spear in the forward direction. The amount of water striking runner reduces. Whereas spear is moved forward direction, the amount of water striking the runner reduces. but the runner due to inertia it have some movement revolving for a long time. To stop the runner in a short time, to reduce the to stop the runner in a short time, a small nozzle is provided which directs the jet of the water on the back of fence. This jet of water is known as braking jet. They will ask what is braking jet. Now we need to understand the velocity triangles and work done for the Pelton wheel. Very important one, and you will get a one essay question. Figure shows the shape of the bucket vanes of the Pelton wheel. The jet of water strikes the bucket at the splitter, which split off the jet into two parts. The part of the jet guides over the internal surfaces. The part of the jet, two parts. One part is guides over the internal surfaces and come out at the outer edge. Second one shows the direction of the bucket at the jet direction. The splitter is inlet tip and outer edge of the bucket is outer tip of the bucket. The inlet velocity triangle is drawn. The inlet velocity triangle is drawn at the splitter, and outlet velocity triangle is drawn at the outer edge of the bucket. If you see, already we discussed about this in class. Whereas jet of water is striking at an angle alpha, whereas u1 is velocity of the runner at one end, whereas v1 is a vector quantity. We have magnitude and direction. In case it's a vector, for resulting vector we will have to additionally we have two another vectors, vw1 and vf1. Vf1 nothing but flow velocity, vw1 whirl velocity at point 1, and we have that relative velocity. In case water and runner is moving with a different speed, so we will get the relative velocity, and relative velocity making at angle of theta. Same case, outer edge, the water flows inside the jet and along the surfaces, internal surfaces, and VR2 relative velocity between water and runner, and again we complete this velocity triangle, Vf2 and u2 plus Vw2. V2 components, Vw2, Vf2. It's making an angle phi, and V2 making an angle beta with respect to whirl velocity at outlet at point 2. U2 velocity of the vane at point 2. In case of the Pelton wheel, u1 and u2 are same, so the problem will be, so formula will be different. So we consider the here this is the general one. This is the general velocity triangle for inlet and outlet. We seen that the inward radial flow turbine. But in case of Francis turbine, outlet velocity is 90 degrees to turbine blade. So Vf2 will be there, V2 is there, U2 will be there, remaining two are 0. Whereas Vwt is 0, V2 is equal to Vf2, beta is equal to 90 degrees. Again, water is striking at the splitter where the velocity V1 and outer velocity V2, VR2 relative velocity at point 2, and U2 at point 2 the velocity of the vane, whereas Vw2 whirl velocity, Vf2 flow velocity at outlet, whereas Vw1 whirl velocity at inlet 1 at point 1, U1 velocity at point 1, Vr1 relative velocity at point 1. Here we are giving direction in a z direction, directly straight line. So we did not have that velocity triangle. This is a special case like that, the Pelton wheel. Whereas net head is acting on the Pelton wheel, you already seen this one is hydroelectric power plant layout. Whereas net head is equal to Hg minus Hf. Hg minus nothing but gross head. Hf is nothing but Head loss due to friction 4F LV square by 2ZD, whereas D is diameter of the penstock, capital D is diameter of the wheel, and N is speed of the wheel in the RPM, D is diameter of the jet. Whereas V1 is equal to, we already know that V1 is equal to root 2GH. Already it is seen in say many subjects. V1 is equal to nothing but root 2GH. After Bernoulli's equation, solving of Bernoulli's equation, we came to know that V1 is equal to root 2GH. Whereas U1 and U2 is in Pelton wheel is same, so U is equal to nothing but pi d n by 60. In case of velocity triangular, the inlet will be straight line, whereas VR1 is nothing but V1 minus U1. VR1 is nothing but V1 minus U1, whereas velocity of the U1 is equal to U2, so V1 minus U, whereas VW1 is equal to V1 is equal to V1, and alpha is equal to 0, water is striking at 0 angle, theta is equal to also 0. Whereas from velocity triangle at the outlet, VR2 is equal to V2 is equal to VR1. So there is no relative velocity. VW2 is equal to VR2 cos phi minus U2. This is based on trigonometry, whereas cos phi is equal to nothing but VW2 plus U2 by VR2. We need VW2, so here it's come VR2 cos phi minus U2. The force exerted by jet of the water in the direction of the motion is given by force, mass into momentum into momentum, nothing but rho a V1 into velocity VW1 plus VW2, whereas area of jet A is equal to pi by 4 d square. We need work done. Here we force exerted rho a V1 VW1 plus VW2, whereas work done we need into velocity rho a V1 VW1 plus VW2 into U. Why here comes U means same velocity, U1 is equal to U2, but in case of other turbines, you will get VW1 U1 plus VW2 U2. Whereas power is given by rho a V1 VW1 U1 plus VW2 into U by 1000 kilowatts. Power we calculated in the kilowatts. Please remember this kilowatts. Work done per second per unit weight of the water striking the per second. Here we already known that the work done rho a V1 VW1 plus VW2 into U, whereas weight of the water striking, how much weight of the water striking per second, nothing but rho a V1 into Z. If you cancel out 1 by Z, VW1 plus VW2 into U. Whereas energy supplied to the jet at the inlet is form of kinetic energy. We already known that we are giving at the inlet kinetic energy, nothing but half mv square. M is nothing but rho a V1 into V1 square. So we need, if you need hydraulic efficiency, work done per second by kinetic energy of jet per second. So work done per second rho a V1 VW1 plus VW2 into U by kinetic energy of the jet, half rho a V1 into V1 square. We already cancelled out 2 into VW1 plus VW2 into U by V1 square. Whereas VW is equal to V1, you already know that VR2 is equal to V1 minus U1. You already know that VR2 is equal to V1 minus U. So VW2 is equal to VR2 cos phi minus U2, VR2 cos phi minus U. Directly we come to conclude that V1 minus U cos phi minus U. So hydraulic efficiency of the turbine, work done per second, kinetic energy of the jet per second, whereas efficiency of hydraulic efficiency 2 into V1 minus U cos phi minus U into U V1 square, 2 into classification. simplification, sorry. Whereas V1 minus U 1 plus cos phi U by V1 square, hydraulic efficiency. In case of hydraulic efficiency, we need that what is the maximum value we can obtain in the hydraulic efficiency, where, when, what is the condition we get the maximum efficiency, so that we derivative with respect to velocity, ఎంత velocityలో మనకు hydraulic efficiency అనేది ఎక్కువ ఉంటుంది. So d by du efficiency of the hydraulic efficiency, if you know well the derivations, 2u v1 minus u 1 plus cos phi minus v1 square, we will derivate this is constant, whereas d by du 2u v1 minus 2u square, whereas 2u v1 minus 2u square we need to go into do derivative, u is equal to 1, 2v1, whereas 2u square 4 into u is equal to 0, nothing but we get a condition u is equal to v1 minus 2, whereas we get the hydraulic efficiency is maximum hydraulic efficiency at u is equal to v1 minus 2, whereas u is velocity of the vane, v1 is velocity of the jet. In this condition we get the maximum hydraulic efficiency. If you go for the if you substitute the same hydraulic efficiency value, v1 is equal to u is equal to v1 by 2 in the above formula, we got that 1 plus cos phi by 2. If in question says maximum hydraulic efficiency, you can go directly 1 plus cos phi by 2 if they are not mentioning that v1 value and u value. So some points to remember in the Pelton wheel, that v1 is equal to cv 2gh, nothing but coefficient of velocity, cv 0.98 to 0.99. If you not remember this value, directly remember one value, 0.99 value. The velocity of the wheel at u is given by u is equal to phi into 2gh, whereas pi is speed ratio. The value speed varies from 0.43 to 0.48 maximum. They will give provided in the provide this data in the question itself. If not, substitute some number, some 0.50, 0.40. The angle of deflection of the jet through the buckets is 165 degrees. If no angle of deflection is given, a angle of deflection kuda ivvakapothe, take it as 165 degrees. The beam diameter or pitch diameter d of the Pelton wheel is given by u is equal to pi d n by 60, nothing but d is equal to 60 u by pi n. Jet ratio, nothing but pitch diameter of the Pelton wheel to the diameter of the jet, capital D by small d, is equal to 12. If most of the cases m is equal to 12. Whereas number of buckets on a runner is given by z is equal to 15 plus capital D, pitch diameter of the Pelton wheel, d, diameter of the jet, nothing but 15 plus 0.5 meters. If you see the questions, if you can extract the data and remember the formula and velocity triangle, it will be easy for you. The Pelton wheel has a main bucket of speed 10 meter per second. He given 10 meter per second velocity, and jet of water flowing at the rate of 700 liter per second. If they given 700 liter per second, nothing but is q, and or else they will mention it flow at a rate of under the head of 30 meters, h is equal to 30, capital H. The buckets deflect the jet through an angle of 160. They given angle of deflection 160. Calculate the power given by the water to the runner and the hydraulic efficiency of the turbine. Assume the coefficient of the velocity 0.98, nothing but cv. Speed of the bucket u1 u2 is equal to 10 meter per second. Discharge q is equal to 700 liter per second, nothing but 0.7 meter cube per second, or else if you convert centimeter cube per second. Head of the water h is equal to 30, angle of deflection 160, coefficient of velocity cv, velocity of jet v1 is equal to cv into root 2gh. cv given 0.98, 2 into 0.98 into 30, whereas you will get the V1 value. If you get the V1 value, we will get VR1. VR1 nothing but V1 minus U1, 23 minus 77 minus 10, whereas VW1 is equal to V1, 23.77. Same, VWT is equal to VR2 cos phi minus U2. We given the angle of deflection nothing but 180 minus 160 degrees. Whereas work done by the jet on the runner is given by rho a V1 VW1 plus VW2 U. Directly we can substitute values. Power given to the turbine, work done by 1000 kilowatts, whereas hydraulic efficiency 2 VW1 plus VW2 into U by V1 square. Simple formulas. If you remember the formulas and velocity triangle, we can if you can extract the data, it will be simple. You will get the up to 12 marks, 8 to 12 marks.